Hello, welcome back to the laws of exponents. Okay, first, and this says laws of exponents and factoring, but this is just laws of exponents. Now, I am going to explain first what we're going to be doing. These are definitions, not theorems or things that you prove. These are definitions. And so let me explain the difference between a definition and a theorem. A theorem is something you can prove to be true, whereas a definition is something that is defined. In other words, we know what a cat is. A cat is defined to be a cat. A cat is not a dog. It's a cat. Okay? Now, a cat can have dog-like properties, but it's a cat. A dog can have cat-like properties. Like my dog acts like a cat at times, but it is still a dog. So, these are definitions. These are what they're defined to be. I can show kind of how they can sort of be true, and kind of like I did with the properties of mathematics. And that's kind of what I'm going to do. And I'm going to show you also how these relate back to my pyramid and why my pyramid kind of helps generally with all of mathematics. So, first off, let's start with defining what an exponent is. So, for example, say that I have, what does it mean to say x to the 6th or 6 to the 5th? So that means 6 times 6 times 6 times 6 times 6, 5 times. So that is 6 to the 5th. All right? And we call the base is 6. I'm trying to write and it's not writing. Now let's get the thing. So we have 6 5 times, and the base is 6 and the exponent is 5. All right? Now if we wanted to say x to the n, then we would have n x n times. All right? So now let's go on to our properties. Okay. So let's talk to an example here. So say that I have a to the m and a to the n, and I wanted to show you that that equals a to the m plus m. So say that I had a cubed times a squared. So if I write this out, so that's a times a times a, so that's a cubed, times a times a, and that's a squared. So how many a's do I have? I have 1, 2, 3, 4, 5. So that's a to the 5th because I had 5 of them. So now let's use the little property. So that's a to the 3 plus 2. Well, 3 plus 2 is 5, so that's a to the 5th. All right? Now, I'm going to draw my little pyramid here. So I want you to notice something here. So here's grouping. Here's exponents. Now, forever I will use EXP equal to exponent. Okay? Then I have, and I'm going to just write it this way, I have multiplication and division, and I have addition and subtraction. Now remember what I said when I first did the pyramid, that I said I had to have multiplication over addition? Right? Remember I said that I had to keep that relationship? Notice that if I'm multiplying my bases, what do I do to my exponents? I add them. Now, I want you to see the next property. Okay? The next property is that if I'm dividing my bases, what am I doing to my exponent? So if I divide my bases, then what do? I subtract. So here in my pyramid, it tells me what I do to my bases if I'm multiplying, I add, if I divide, I subtract. That is the reason why you have to keep the vertical, and it's so important. Okay? So, notice the pyramid tells us the operation. Okay? It's just below. And we'll see this again when we get to several different things. Okay? It's not just in laws of exponents that it tells us. Now let's show you an example here. Okay? If I have a cubed over a squared, this is a times a times a over a times a. Well, if I cancel these out because they're the same, I'm left with a. All right? But if I use the property, that's a cubed minus 2, which is a to the first. Notice I get the same answer both ways. All right? Now, another way to think about this is to use the next definition. The next definition, says that if I have a to the negative exponent, then that's 1 over a. So if I go back to my example up here where I had a cubed over a squared, if I wrote this as a cubed times a to the negative 2, now I added those, that's a cubed plus negative 2, then I still get a to the first. So that's 3 different ways that I have shown you that I still get the same answer. Now, as I said before, these are all definitions. The reason I didn't leave any space to do this is this is how sorry, technical difficulties. This is how this is defined to be. All right? Now, let's go on and show you how a to the 0 is, how it kind of works. Let's think about it this way. This is 1. If I have a to the m over a to the m, so that means that if I have a fraction over a fraction where they have the same exponent, then that means they're the same thing. All right? So that's 1. But using the subtraction, so that's a to the m minus a to the m, then that tells me that that's a to the 0. So in other words, I have shown that a to the 0 equals 1. Kind of slick there. I'll let that digest for a minute. Now, I want to look at number 5. And I'm going to go here and I'm going to draw our pyramid again. I have grouping, exponent, multiplication, division, addition, and subtraction. Okay. Notice that multiplication is on top of addition and division is on top of subtraction. Notice that exponents are on top of multiplication. Okay? In the pyramid, it works so that for laws of exponents, we're always doing one thing down. So here, the way you can think about this is that if I look at exponents, then the next thing down on the row is multiplication. So if I have something raised to a power, then I'm going to multiply because I'm going to go down a step in my pyramid. So if I have an exponent raised to an exponent, then I'm going to multiply. If I have multiplication, then I'm going to go down, and that's addition. If I have division, I'm going to go down, and that's subtraction. And that's why we layer our pyramid the way we do. All right? One thing to remember is that, remember in distributive property, I have A outside and I have B plus C. A goes to everything that's inside, right? So if I have an M outside, M goes to everything that's outside. That is not true, however, if I have A plus B squared. That is not true there because that's a whole different animal. And we will get to that in the next video. Okay? Now, let's talk a little bit about, this is the wrong example. Whoops. Okay, let's get a little bit here for number 7. What you need to remember here is this is a number raised to a fraction. So we have a to the 1/2. Well, we know that that is the square root of a, but this is still to the first. Well, what if I had a to the 3/2? Well, that would be the square root of a cubed. Okay, so notice that the denominator is the root. Okay, and the numerator, is the exponent. All right, and that's what's important to remember there. All right, now let's go ahead and let's look at some examples. All right, first I want to make some observations and some things that you need to remember. First thing is, fractions are okay for answers. Fractions are okay for answers. You must have the same base. Okay? And the biggest thing is use order of operations. A lot of people like to work these questions, and I realize that there are many different ways that you can work these questions, but I want you to use the order of operations because it really helps the students to use these to use the order of operations for this it really helps the students if you use the order of operations for these questions, and that means simplifying inside the parentheses first. Unless you have a 0 on the outside of the parentheses. And the last thing is, do not add an equal. do not add an equal sign unless it comes with it to begin with. I never add an equal sign unless I have one to begin with, because there is just too much. If you add an equal sign, you're changing the question. You're turning it from an expression into an equation, and that's not good. All right, so let's start with this first one. The first thing I'm going to do is I'm going to combine my numbers. So -5 times 2. Then I have x cubed times x to the -4. And then I have y to the -8. And these are all multiplication signs here. Times, and I'm going to put just a normal big multiplication in between here so that we can separate each part. Y to the -2. So this is -10 x. I add these two to the 3 plus -4. Y to the -8 plus -2. So this is -10 x to the -1, y to the -10. Now, I'm moving over here so I have a little bit more room, but notice I did not put an equal sign. I drew a big arrow to tell me where I'm moving to. So my answer is going to be -10 over x, y to the 10th. And I'm going to box my answer. Okay. Now I'm going to have y to the 13 minus 40, since I have the same base. Now again, I like working questions vertically, so I'm going over to the side of the page to work the question. Okay, so there was that one. This one, what I notice is that I have a big 0, so this entire thing is raised to the 0. Anything to the 0 is 1. So there is no work here. The answer is just 1. Okay, now, again, I'm going to do this in parts. So I'm going to have 28 divided by -14 times x to the 3 minus 2 times y to the 5 minus 8. So that's -2 times x to the 1 times y to the -3. -2 is a number, x over y cubed. That is my answer. -2 is a number. It is not, the negative is not on the exponent. So I leave the -2 alone. Now, this is the one where I'm talking about working as order of operations. So I'm going to just work with this part, but I want to rewrite the entire question every time. So this is 6 over 4, big times a 2 minus 1, b 4 minus 3. And all of that is squared. So this is 3 halves, a to the first, b to the first. All of that squared. Now I'm going to square each part. So that's 3 squared over 2 squared, a squared, b squared. So that's 9a squared b squared over 4. And that is my final answer. Okay? Now, again, I'm simplifying inside the parentheses first. Now, I realize that all of you see that, oh, well, you could do the -3 and multiply each term by -3. I realize that, but what do the order of operations say? The order of operations say to simplify inside the grouping symbol first. And it's important to stick to those order of operations so that your students learn them. So 2a cubed over b to the fourth, parentheses, c to the 0 is 1, negative 3. Now, I'm going to get rid of the negative exponent by flipping the entire thing. So I'm going to have b to the fourth over 2a cubed, and all of that is still going to be cubed. Now I'm going to go up here. So this is going to be b to the 12th over 2 cubed a to the 9th. And so my answer is going to be b to the 12th over 8 a to the 9th. Okay? And the next one, simplify my numbers. So I have 1 over 6. I'm sorry. Let's start over. I have 3 over 6 times x to the negative 2 minus 3 times y to the 3 minus a negative 5 times z to the negative 1 minus a negative 2. Now, I do realize that there are other rules and other ways that you can work this. I could move all the negative exponents to the top and all the negative exponents in the top to the bottom and do all sorts of things. But right now, I'm trying to focus on how to use those laws of exponents. Okay? And that's why I'm doing these questions the way I'm doing them. So, the 3/6 is 1/2 times x to the negative 5 times y to the 8th. I was doing that right. Times z to the 1st. So this gives me y to the 8th z over 2x to the 5th. And again, I'm going to simplify inside the parentheses first so that I can follow those laws of exponents. So I have 5/2 times x 1 minus 4 times y to the negative 3 minus 1 times, and that z just becomes z to the 3rd in the top. All of this is raised to the negative 2. So this becomes 5/2 x to the negative 3, y to the negative 4 times z to the 3. So that's 5z cubed. Again, that should have been raised to the negative 2 over 2x cubed y to the 4th, all raised to the negative 2. Now, the negative exponent, the negative flips it, and I wish y'all could see me because I'm actually flipping it with my hands. 2x cubed y to the 4th over 5x cubed, undo, that should be 5z cubed, and now I'm squaring everything, and so my answer should be 2 squared is 4, x 2 times 3 is 6, 4 times 2 is 8, over 5 squared is 25, and 2 times 3 is 6. And let's see if we can write that 6 a little neater. And there we go. Now, the last thing in this section is how to simplify square roots. So what we're going to do is the first one I'm going to rewrite 12 as a square. The second one I'm going to rewrite 125 with a square. And for the last two, I'm going to rewrite them as powers because their roots aren't squared, their roots are to the third and to the fifth. So how can we rewrite 12? 12 is 4 times 3. So this is going to be the square root of 4 times the square root of 3. Well, the square root of 4 is 2 times the square root of 3. Now, I don't know if you've noticed, I put a tail on my square root. That's so that you know where the end of the square root is. It will be helpful as we come later, as we get to it later. 125 is 25 times 5. So that's 25, square root of 25 times the square root of 5. So that's 5 times the square root of 5. Woo! Now let's talk about 24. So 24 is 8 times 3. 8 is 2 cubed. So this is going to be 2 cubed times 3. So this is the cube root of 2 cubed times the cube root of 3. Well, the cube root of 2 cubed is 2 times the cube root of 3. Okay? Now, 64. 64 is 2 times 32, which is 2 times 16, which is 2 times 8, and 8 we know is 2 cubed. So 64 equals 2 to the 6th, or it equals, we want it as the 5th root, so this is 2 to the 5th times 2. Right, we got 6 because this is 1, 1, 1, and we had 3. So this is 2 to the 5th times 2, and these are 5th roots. So this is 2 times the 5th root of 2. Okay. Please email me if you have any questions. Thank you.